Okay, we have here today a pretty interesting looking integral on the board. We've got the integral from -1 to infinity of 1 plus x to the 13th over 2 plus x to the 15th dx. So what I did for this one, I actually got this from the UNSW integration bee, but I changed a few things to make it work out the way I wanted. So it's kind of an alteration of a problem from UNSW. And I'm going to do this one using two different methods, but both go pretty quick and I like both methods. So I just wanted to show a couple ways to do this. So for my first method, what I'm going to do is I'm going to make my u substitution just focusing on simplifying the denominator. So to do that, I'll make my u equal to 2 plus x. And then I could find a value for x. We could write x as u minus 2, I suppose, and take a derivative. And so dx is going to be just du. And actually, while I'm at it, I see that we're going to want a value for x plus 1. That's really easy to do. Let's just add 1 on both sides here. So for x plus 1, that's going to be the same thing as u minus 1. And we'll go ahead and we'll make the substitution. So first of all, if I plug infinity in here, infinity plus 2, that's still infinity. If I plug minus 1 in here, our lower bound becomes just 1. Now, like I mentioned, the denominator is going to simplify, so we end up with just u to the 15th power in the denominator. And then we have our value here for x plus 1. This is just going to be u minus 1 to the 13th power, and we just have our du. Now from here, I want to do a little algebra on this. Let's take our u to the 15th. I'm just going to split this up because we put a 13th in the numerator. I'm just going to write u to the 15th as u to the 13th times u squared. And then now, because we've got the same exponent, what I'm going to do is rewrite this, but I can write u minus 1 over u within one exponent. Like I can write it all to the 13th and then divide my u in. We end up with 1 minus 1 over u. But let's not forget this piece hanging out right here. So this is going to just give me like a 1 over u squared here du. But now the interesting thing at this point is this actually works pretty well with this. And so I'm going to do another substitution now. I'm going to call this my t. We could reuse x, but let's just use t to keep it fresh. So we're going to have 1 minus 1 over u for t. If I take a derivative, my dt, this is going to end up being just 1 over u squared du. But that's perfect because that's what we have right here. So this becomes our dt. So now we'll go ahead and we'll do another substitution. Now if I take infinity, if I plug it in for u here, well then this piece is going to 0, so we end up with just 1 for the upper bound. And then when I plug 1 in here, 1 minus 1, now we have 0 here. Then again, this is t, so we're going to have t to the 13th dt. And so now we're just integrating with power rule. This is real easy, right? So we got t to the 14th power over 14. Just need to evaluate this from 0 to 1. When I plug in 0, this is just 0, so all I need to do is plug in 1, and this is going to give me my solution, 1 over 14. Okay, now on to method 2. What we're going to do again, we're doing a u substitution once again. So for the u substitution, last time we substituted the denominator, this time we'll just substitute the numerator, and we'll say u equals 1 plus x. Let me get a value for this 2 plus x while we're at it. So if I added 1 on both sides, we can say u plus 1 is going to be the same thing as 2 plus x. If I take a derivative, we see that du is going to be just dx. So I go ahead, make my substitution. So again, infinity, if we add 1 to infinity, still infinity. We plug minus 1 in here, 1 plus minus 1, the lower bound is going to be 0. Now again, for our numerator, this is going to be, because we've simplified the numerator to just u to the 13th. And then for 2 plus x, this is going to become just u plus 1 to the 15th. But now at this point, we can't just do the same trick we did last time. We can't just divide easily the u plus 1 into the numerator. It's not going to work the same way, but luckily we do have a formula for this. Okay, you might have guessed it. What I want to do is use one of the many forms of the beta function, and we have our formula over here to the right. All we need to do is notice the similarity between our formula and what we have here. The integral is going from 0 to infinity. We get the same, we have it in u, of course, but that doesn't matter. And so what we just need to do is find our values for z1 and z2, and then we can go to the gamma function and calculate this. So I think the easiest way is going to be calculate the z1 value in the numerator first. So we're saying z1 minus 1 is going to equal 13. So if z1 minus 1 equals 13, then of course z1 is going to be just 14. And then we're saying our exponent in the denominator is just going to be the sum of z1 plus z2. So we're saying z1, which is 14, plus z2 equals 15. So z2 is going to be just 1. So to calculate this, we're just going to write this in terms of the gamma function. So we're going to write this as gamma of z1, which is 14, times gamma of 1 over the sum of these two, gamma of 14 plus 1. So it's just going to be the gamma of 15. And now we just want to get our solution as like a numeric value and get rid of all this gamma stuff. So what I'm going to do is use this formula that for gamma of n, this is going to be the same thing. This can be converted to a factorial and written as n minus 1 factorial. So now just looking at each value, gamma of 1, that's going to be 0 factorial or just 1. So I'm just going to cancel that off because the 1's not going to do anything for us. Gamma of 14, that's just going to be 13 factorial. Gamma of 15, subtracting 1 again, 14 factorial. So just plugging this in here for our gamma of 14, we have 13 factorial over 14 factorial. And then of course, we'll write our 13 factorial. For 14 factorial, I can write this as 14 times 13 factorial. Cancel this, and we're left with our solution, just 1 over 14. Okay, so I really like that one. I like both methods really, so I don't even know what to choose. So let me know in the comments which you prefer, beta function or just the straightforward u substitution. We'll stop it there. Thanks so much for watching. Have a great day.